All right, 1.8 multiplying complex numbers. So let's go back and look at, remember that I is equal to the square root of -1, right? And I squared is -1. I squared is -1. What would I cubed be? That's a t, isn't it? I cubed would be I times I squared, right? Which would be -1, or I, and -1, so that would be negative I. I to the fourth is I squared and I squared, so -1 times -1, so 1. All right. I think that's all that we're going to need to know from this, but we're going to need to know that I is root -1. We won't really need that one. I squared is -1. I cubed is -I, and I to the fourth is 1. All right, we're going to need to know those for this paper. Looking at, we'll do number 2 here. Well, I'll set up number 1 for us. It's listed as squared there. What that means is we have -3i times -3i. Right, and I'll let you finish that one off. Number 2, we'll multiply the -6 and the 3 to give us a -18i. And that's it. Right, nothing crazy on that one. Number 4, they're all multiplied together, so I'm going to multiply my constants first. I have -2 and -8 gives me a positive 16, times a -3 gives me a -48. I have an I and an I, so that gives me an I squared. Now we don't leave it as I squared because we know what I squared is. I squared is -1. So this is -48 times -1, which is plain old 48. All right. Let's look. Number 6 is pretty easy. Let's look at number 8. Because we have this subtraction sign in there, we can't do it like what we did the last problem we did. To complete this one, I'm going to first multiply my first piece here, my first 2 pieces there. So this will be a -7i squared. Then I still have my -1 minus 5i. Now -7i squared, I know that I squared is -1, so this turns this into a 7. And now the problem should be pretty easy. We have a -7 minus 35i. And there we are. Let's look and see if we can find one that's harder. Let's do number 14. Again, since we have some pluses and minuses in there, we're going to just do 2 pieces at once. We can't do all 3 at once. So I'm going to look at just the first 2. This will be 40i plus 16i squared. And then I still have my -6 minus 7i. Now we know what I squared is. I squared is -1, so this is really a -16, right? So we have 40i, -16, -6 minus 7i. Now you might be saying here, well, Mr. Carrington, why did you put the I one in the first? I did that just because that's the way the problem lined up, and we're not done yet, so we don't have to be in standard form yet, okay? In the middle of the problem, it doesn't really matter what the order is. All right, multiplying this one out. I'm going to multiply like that and like that, just like normal. 4 times 6 is 24, so this will be 240, -240i. And then this will be 7 times 4 is 28, so this will be a -280i squared. And then -16 times -6 gives me a 96. And 16 times 7 is 112i. The only one that really needs to change is this piece there. That turns this into a positive 280, right? So I'll take 280 and 96. That gives me the real part, which is 376. And then for the imaginary, I take negative 240 plus 112. That's a 113 that I typed in. So this would be, minus 128i. And there we are. Number 16 works a lot like number 14 does, and I think you guys will be just fine. Again, I will post the answer key on Classroom. The things to remember, and I guess we don't need, what's the highest exponent we'll get to? Yeah, as long as you stop in the middle of the problem, kind of like how I did right here, I think the only thing that you're going to need is to know that I squared is negative 1. If you don't stop there, you'll need to know that I cubed is negative I. I don't think we're going to have that run into that issue. And if you do, you can email me. I'll help you out. So good luck on this. Do well and check your answers. All righty. Bye-bye.